So let us look at this AC circuit problem as we are seeing it here. This is all about the AC circuit problem. So what we are being asked is to find the angular frequency. Solution. We have been challenged to find the angular frequency in the above AC circuit. The problem here is that the AC circuit is quite different from DC circuit, for sure, because in your AC circuit we are encountering two things, that is phasor and frequency. As you can see that in AC circuit, the current is not directly proportional to the voltage. The voltage drags behind the voltage lags 90 degrees behind the current. So this is where the problem is. Now the movement of the AC circuit, like this, it is like this phase, sorry. It is. Now looking at the amplitude, looking at the wavelength and the voltage current relation in AC circuit is quite different to DC circuit. Now this is what we are going to do here in this question, to look at the relationship that is there between the AC components described here. Here we are having 600 ohms resistor. Here we are having an inductor 3.2 Henrys. Here we are having a capacitor. Now these three components are used to transfer the current electricity from the AC sinusoidal form to DC current. This is what we are going to deal with right now. So directly let us go to the solution of this AC circuit. One, we need to understand the problem. That we have been given a circuit with voltage source VG, a resistor R, an inductor L, and the capacitor. C. We are given the current source here. We are given also the current source. Source I naught and the voltage as pseudo function. The two, the current and the voltage as sinusoidal functions of time, as shown here below here. This one and this one. So here, our goal here, as you can see here, our goal with this one, with this, is to find the angular frequency. This is what we have been asked. So let us look at this. Our goal is to find the value of W, angular frequency. Frequency in our circuit. So what follows here, second, to convert the phasor representation, converting the phasor representation. So first, let us convert the given sinusoidal function, that is A cos Wt plus psi, to a phasor, which is A where A is the amplitude and the psi is the phase angle. Also, A sine is, this one is equivalent to A cos we are seeing that here because I've said that in this AC circuit the voltage source lags the current source by 90 degrees. That's why here we are having 90. So we are converting this A sin omega t plus psi is equivalent to A cos Wt plus psi minus 90. So here we need a conversion. All right. Then current I naught is equal to I naught is equal to 40 sine omega t plus 21.87 milliamps which is equal to 40 cos omega t plus 81.87 degrees phase angle minus 90 milliamps, which is equal to 40 cos WT minus 68.13 milliamps. Sorry, here it is 40 cos. Again, the phasor representation would be so the phasor representation is equal to 40 negative 68.13 milliamps, which is equal to 0.04 phasor negative 68.13 amps. This was milliamps. This one was milliamps, but now we have converted it to amps. That's why we are having 0.014. Again, voltage source VG is equal to 40 cos omega t minus 15 voltage, as it is shown here, as it has been marked in your question here. So therefore, the phasor representation of the voltage Vg is equal to -40 -15 voltage. Now, the other step, the next step, to calculation of the impedances of the resistor inductor and the capacitor. Resistor R in AC circuit is named as ZR, impedance resistor, which is equal to R is equal to 600 ohms. Inductor R, the impedance inductor is given by ZL, which is equal to JWL, whereby J is the imaginary unit, Hope you have done complex numbers, but now complex numbers here in this topic are coming because now it is because of the difference between the current flow and the voltage, because the voltage, as we have said earlier, lags the current beyond 90 degrees. It is because of that, in order to make the good presentation, the mathematical way, it will be represented as an imaginary number, right? So here we have the inductor being presented as JW 3.2, which is equal to J 3.2 omega. Here we have capacitor. The impedance capacitor is ZC, which is equal to 1 over JWC, which is equal to negative J over WC. Hence, the impedance capacitor is equal to 1 over JWC 2.5 times 10 per negative 6, which is equal to negative JW 2.5 times 10 per negative 6. By further simplification, which is equal to J (4) times 10 per 5 over omega ohms. Now, let us apply Ohm's law. In phasor form. It's equal to total impedance is equal to impedance resistor plus impedance inductor plus impedance capacitor. which is equal to, we are being given values. The impedance resistor is equal to 600 ohms plus impedance inductor J 3.2 omega minus J 4 times 10 power 5 over omega. Again, therefore, Ohm's law in phasor form V is equal to IZ, current times impedance Z. So, therefore, voltage Vg is equal to I current source times Z total. Which is equal to minus 15 is equal to 0.04 times 0.13 times 600 plus J 3.2 omega minus J 4 times 10 power 5 which in turn is equal to, now we are almost approaching the end of this question. Solve for omega, for angular frequency, which is equal to divide, let us divide both sides by 0.0468.13, which is equal to 40 divided by 0.04 which is equal to 600 plus J 3.2 angular frequency minus J 4 times 10 power 5 over W, which is equal to 1000 minus 68.13. Now this is a matter of mathematical simplification. We are getting at the end of this question, which is equal to 600 plus J 3.2 W minus, sorry, I've made a repetition, which is equal to 600 plus J 3.2 W minus 4 times 10 power 5 over W. Now we need to convert the conversion. We need to convert the phasor to rectangular form. Which is equal to 100 and 1000 cos 53.13 degree plus J sine 53.13 degrees. Which is equal to 600 plus J 800 which is equal to 600 plus J 3.2 omega minus 4 times 10 power 5 over angular frequency. So here we need to equate real imaginary parts. Equate parts which equal to 100. 100 is equal to 3.2 W minus 4 times 10 power 5 over W multiply by W, which is equal to 800 W is equal to 3.2 W squared minus 4 times 10 power 5 which is equal to 0. So rearrange terms. You arrange to form the quadratic equation. Rearrange the terms to form the quadratic equation. Which is equal to 3.2 W squared minus 8 W minus 4 times 10 power 5 equals to 0. So up to this stage, let us simplify this expression by using the general quadratic formula. The question becomes, after simplifying, you have found that it is equal to W squared minus 50 W minus 12 and 5, which is equal to 0. Then the quadratic formula is W is equal to minus B minus O plus root B squared minus 4AC all over 2A. Is equal to W is equal to 250 minus O plus B squared minus 4AC so W is equal to 250 minus O plus minus 250 squared minus 4 times 1 times minus 125,000 all over 2 times 1, which in turn, for simplification, that we are having W1 is equal to 250 plus 750 divided by 2, which is equal to 500, or W2 is equal to 250 minus, which is equal to 500 over 2, which in turn we get negative 250. Since angular frequency must be positive, we take the positive solution. We take the positive solution. That's which is angular frequency is equal to 500 radian per second. That is the final answer of what we have been looking from the very beginning. Okay, so let me explain the use of these components. We need also to explain the use. This is the final answer, the explanation about the use of the components forming the circuit, the above circuit. One, an inductor. An inductor is just a coil. It is like that. It is represented as this one, a circuit, an inductor. So this opposes changes in the current. This is because in AC circuit, the current changes That means it is not stable. It is not always stable. Not always stable. So the inductor presents an impedance, yani opposition, inaleta ukinzani, impedance ya impedance to current flow, So it is because of this it opposes the current flow and it stores energy. Thus, in case the circuit is switched off, the inductor restores energy to continue the current flow in the circuit. The resistor plays the role of resisting the high current flow in the circuit, while the capacitor smooths the AC signals that in turn may damage the circuit component. So thank you very much for watching, and that's what I wanted to present to you today about the AC circuits and how they function. Thank you very much.